tonight's kit build is accompanied by peanut butter and jelly sour beer from Fort Garry Brewing in Winnipeg. Anybody who's watched this channel before knows that this is far from my normal style of beer. This is something that was gifted to me by someone who shall remain nameless. But what the hell, we'll give it a shot. Oh, okay, there's the peanut butter in the aftertaste. I wasn't getting it initially. It tastes kind of like if you were to mix like those sour, dry, powdery candies into beer. Yeah. I mean, I'm going to drink it. It's beer, but I'm going to have words with my buddy who gave that to me when I next see him. I'll buy him a real beer. Anyway, that's not why we're here today. We are here for this kit build. A couple weeks ago, during the mailbag, I asked which kit you would like to see me build first out of the ones that I got, and this one was by far the highest voted. This, as you can see there, is a mini power power supply, DC 5 to 24 volt input, outputs at plus 12 and minus 12 and plus 5 and minus 5 and plus 3.3 volts, all simultaneously even. Fair number of components, but nothing too exotic. Probably the most unusual and the ones that are going to be the most interesting solder are these three inductors on here. Other than that, we got a whack of little heat sinks. So each of these components that sits on a big heat spreading pad on the board also gets a heat sink stuck on top of it. We have a 7812, 7805, which are 5 volt and 12 volt positive voltage linear regulators. We have a 7912 and a 7905, which are negative voltage linear regulators at 12 and 5 volts. And then we have the 1117-3.3, the 3.3 volt linear regulator. What else can I say about this? It's a nice, thick fiberglass circuit board. Kind of a cool red screen print, or not screen print, solder mask on it. That's pretty neat. Some surface mount components, some through hole. And it's based on this XL6008 chip. It is a 60 volt 3 amp switching current boost buck boost inverting DC to DC converter. It can take between 3.6 and 32 volts input. The board that I've got here says it takes 5 to 24, so that fits. But with 3.6 volt input, if it actually will work from there, then I could probably power it from a lithium-ion battery. Have to try that. Anyway, it comes with a typical schematic to create an 18 volt switching power supply. So that's kind of neat. And I'm guessing that's going to be pretty similar to what's on the first part of this board, just and then followed with the various linear regulators on the output side. That didn't get any better. But this wasn't that hard to trace out, actually. It is a double-sided board, but everything's fairly straightforward. There aren't a lot of hidden tracks. So we have the USB and we have the switching barrel jack. Oddly, the barrel jack switches on the negative side, not the positive. So that allows you to leave the USB connected and just plug in the barrel jack, and it will take over and disconnect the USB. Then we have a fuse. We have a power LED and resistor for it. We have a couple of capacitors, 22 microfarad and a little tiny ceramic 104, which is it 10 nano, I think? Then that's just to smooth out the incoming power. Then we have the XL, what is that, 6008. It's got 5 pins. It's only using 4 of them, V in and ground, obviously. So this switching output will be creating a square wave, which will be pulsing the inductor, creating magnetic field in it, and then when it turns off, the magnetic field will collapse and push current out this direction. Because it's all spiky and AC, it will pass through this 22 microfarad capacitor. There's a voltage divider for the feedback. Then from there, it will go through a diode to rectify it, because that's what diodes do. Big 470 microfarad capacitor to smooth it back out. And there is the positive voltage supply. I'll follow that line on the next page in a second. Meanwhile, Also coming off this same pulsed output, we have essentially the same circuit again. 22 microfarad series capacitor, diode, inductor. Oh yeah, I forgot that diode, that inductor there. Inductor there, another 470 microfarad. But this time, the positive side of that is grounded. See, the negative side of this one's grounded. And then the negative side of that capacitor is going to the negative voltage supply. And then the positive voltage supply goes to the two positive regulators, the 7812 and the 7805. The negative supply goes to the 7912 and the 7905. And the 5 volt output from the 7805 linear regulator goes to the input of the 3.3 volt regulator and out to there. On the backside of each voltage, we have a 47 microfarad capacitor for smoothing and reservoir and stuff like that, and a little 104 ceramic capacitor. Again, same as that one over here, just to get rid of any weird high frequency artifacts and stuff like that and further smooth it out. And there are the 5 outputs. Fairly cool, straightforward little circuit when you break it down like that. But I think that's enough rambling on. Let's get to soldering. So as usual, I'm going to start with the resistors. I tend to like to start with the smallest components, also the components which are least likely to be damaged by mistreatment. So that is almost always the resistors. So I'll start with this 12K resistor here, and then the 3 1K resistors. I know that they're the 1K resistors. Well, I measured these off camera. I know a lot of people have trouble with these bluish resistors, even people who aren't colorblind like me. But I always like to measure them just to make sure that the kit's not pulling a fast one on me or doing something stupid. And to make sure that my eyes aren't lying to me, because I never trust the color codes. It's just what happens when you're used to your eyes lying to you about colors. There's one other resistor in the kit. I think, yeah, there's only one other resistor left. So that ought to be, where is the other resistor? I thought I saw it a second ago. Where'd it go? Point it out to me. 2.2K over there. 2.2K, perfect. I mean, it was the only resistor left in the kit, but you always like to double check. Where'd it go? I saw it just a second ago. There. Okay, what should I do next? How about the fuse? It's one of these little poly fuses. UF300 it calls itself. No idea what the value of that is. I tried to look it up, but I didn't see anything obvious. What else while we're in here? Should we do some of the capacitors? There's a bunch of these little 104 capacitors, which, according to my memory aid, is 100 nanofarads, not 10 nanofarads like I guessed earlier. Oops. Anyway, 4 of them go over here. That's the ones on the output side, in parallel with these 47 microfarads. And then there's one more on the input side, again in parallel with that 22 microfarad capacitor. I think before we get too carried away, we'll do these 2 surface mount diodes. One of them's there and the other one's over here. These little buggers. This is going to be interesting. I'm going to use my ceramic tip tweezers to hold them in place. But I'm also going to start off by tinning one pad. I think I'll get the one on the right side just because that makes it easier for my soldering hand. Ooh, let's do the top one on this one, I guess. These ones don't have the leads tagging out the sides. They have the leads curled underneath. You see that? You young guys that don't have shaky hands and have eyes that work can probably do this a lot easier, but it's a skill that you can learn, even an old bugger like me. Now that's down and stuck in place. I'll get this one. There. Mechanically held in place. I can come back in behind that. Hit a Dab of solder on that end. Way too much. And then refold that end again. Good. And do the same thing down here. Solder on that end. Just I'm gonna let it cool a bit so that the other end doesn't shift. Refold that and add some solder. Looks good, I think. That's far too much solder. But it looks like it's electrically connected, which is all I really care about. And the bands are on the right ends. Perfect. So all of the series regulators, the linear regulators, are in surface mount packages, which again, I'm not accustomed to. But that adds to the challenge of the kit. 7905. Sure, we'll start with that one. 7905 goes right down here. So two of the connections are the legs, and one connection is the tab. That should be interesting, because the tab is a big old heat sink. I'm going to have to throw a lot of heat into that to get it to take solder. Let's just do that. Tin up the pad. That one's down, and now the tricky one. And a bit of solder on there just for extra good thermal contact. Go. It worked. It didn't even look too ugly. Awesome. Right, carrying on. Yeah, what's that one I just dropped? Oh, I think that's the 1117 because it's a slightly different physical package than the rest of them. Yeah, 1117 3.3 volts. And this one I have the 3 legs plus the tab to solder. And again, I'm just going to tin up the first pad and then slide them into place while applying some heat. That was a little awkward, but I got there in the end. These ceramic tip tweezers that I bought from eBay or wherever a couple of years ago, they are just the thing for handling these little surface mount components. They don't wick heat away from what you're doing. They're not electrically conductive. They got nice sharp tips to grab on with. And they just work. I like them. Probably should get another set just in case I damage them. But so far I haven't. 7812. It's the positive voltage regulator, and that goes right up there. Tin one pad. Same trick again. I'm just going to repeat this over and over. This thing's big enough that I'm going to risk doing it with my finger. Nope, 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 nope. Bad idea. But I got it on there enough anyway. Tag this one down properly. And refill him and tag him down. Much better. Again, way too much solder. And then this little bit up here. Ooh, I didn't leave enough of the pad showing. Hopefully I can get enough heat in there. To get it to flow down to the board. Yeah, it looks like it did. I think. Yeah, I think it did. So the 805, 5 volt positive goes right there. And there's all the linear regulators on there. I think just because this thing is so small, normally I wouldn't want to put on the fanciest chip that I don't have a replacement for, but in this case, A, it's a power device, so it can probably take the heat, and B, it's going to get kind of crowded in there with all these other things if I don't put it on soonish, so I will do that now. And that will be all the things with big heatsink tabs on them too done. So that'll be nice. Oh, I should have put this on before that resistor. Oh well, live and learn. I'm going to make a mess of that, aren't I? Let's solder the tab down. Even a monkey like me can do that. Okay, I think I'll have to use that surface mount drag soldering technique. Easiest. Solder them all down in a big ugly mess, and then use some wick. Where's my wick? And pick up what you don't need off there. And just to give the wick the best chance of succeeding, I'm going to melt a little bit of flux into it so that hopefully it will pick up any stray solder out of the way there. Theoretically, it shouldn't pull 100% of the solder out, just the excess. Okay, I think that's got it. That took way more effort than I thought it should. Clearly a technique I need to get more practice at. Anyway, onward. That is all of those components. What do we got left? Capacitors. Oh, I missed another 104 capacitor there. Like I said, I try and do the smaller ones, or the ones that are going to be hard to work around first. I'll just tag that little puppy in there, and then we'll carry on. Should I do these inductors, or should I do the capacitors? I think I'll do the inductors first, because they are sort of surface mounty as well, and they may be a little bit hard to get into afterwards. So these are all the same, 330 nanohenries, microhenries probably, I would guess. Oh yeah, let's think about this. Let's do that one first, I think. Because yeah, this one will get in the way. Right. As I was mentioning before, they don't have leads splaying out the side. They kind of tuck right under. Just like those diodes did. So that's going to be a bit of a trick to solder. Again, this is a good kit to practice on, I think. 'Cause it's got a little bit of everything. It's got through hole. It's got surface mount. And it's got big components, and it's got small components. Okay, I think that's just about ready there, and pressure on it, and I felt it melt down. You didn't see it because my big thumb was in the way. Around the pad at this side. Sure, let's get in there, add some solder. I can really feel the mass of the board pulling the heat away. Okay, that looks good. I think I'll just... Oh no, that one turned out pretty well. Okay. Let's do this one next. Yeah, they don't all align in the same direction, so let's see if you can see this. So I'll just heat that up, and as everything melts into place, that should just drop down onto the pad. It didn't, because there's so much mass there. Get out of the way, capacitor. Try and heat both the pad and the component. Wow. That's tricky. A little bit more solder on there. Come on. There. That look like a solder fillet to you? Yeah, and it's mechanically sound. Okay. Now I'll get the top. Hopefully that's not on nearly as big a pad. There we go. That took. I think I'll add just a little bit more solder to the bottom one here, if I can. Wow, is that every sucking heat away? Should probably crank up my iron for these guys. Should I concede to conformity? No, that one's going in upside down. If you can't do it, if you can't deal with that, you're probably on the wrong channel. That sucked down there quite nicely. And just this one. I thought those would be harder. It was just really managing heat that was the issue. So now, what do I have left over here? I have a whole bunch of capacitors and then some mechanical bits. Let's put in some of these capacitors next. I think they're all the same. 22 microfarad, 22 microfarad. Oh no, and then a bunch of 4.7s. Okay. Electrolytic capacitors are a polarized device. There's a negative, which is marked by the stripe on the side, and that on the silk screen is marked by that little shady bit there. So drop him in this way. Sink it right down to the board, I guess. Why not? And this one, we got the right end. Yeah, I do. Okay. Might as well put in the 47 microfarads. Is that this guy? That's a 22. Oh, it goes up there. Okay. There's another 22. Oops. Again, not having a manual or an assembly instruction, you just have to kind of fumble through, which is fine. Should I put the 47s on? Sure. That's one of them. Yep, that is a 47. And white stripe, make sure it goes to the right side. Oh, come on. Just double checking to make sure that they didn't miscount. And that one's a 47. Negative to the bottom. You've probably noticed it already, but I'm just giving the leads a little bit of a bend on the underside here with my other finger, just so they hold in place when I flip the board over. 47, yep. Negative goes that side. Right, let's put in the big capacitors, which are doing the main filtering. 470 microfarad again. Oh, this side has got marked positive and the shade. There's the minus sign on there, so that goes in there. And these two are the most important ones to get the polarity right, because they will be able to pull quite a bit of current into them if you get it wrong, which will cause a fairly spectacular explosion. I'm normally not offended by a spectacular explosion, but in this case, I'd prefer the circuit to work. Next, I will drop in the two LEDs. This one's even convenient. Got the positive end marked, even though it's already got the diode symbol on it. If you look at an LED, there's a flat side there. That's the negative side, or the longer lead is the positive side. And just to double check, you can verify it like that. Right, now all that's left to put in is the output plugs. There's also some header pins that you can put in there to pick up the voltages, but I don't think I'm going to. I'm just going to go with these jacks, or plugs, or screw terminals, I guess is the proper name for them, if I'm actually thinking. Oh yeah, I forgot about that. These things actually have little dovetails on the end of them, so you can slide them together like that and like that and make a nice big block of them. And as long as they've designed the board properly with the pin spacing correct, and they have, then we can do that. I'm just going to slam a piece of white tack or fun tack on there just to hold it in place. It's blue tack, except for it's not blue. Available at all of your most convenient dollar stores. And there we go. That's all in place. Handy stuff, that. I guess we can put in the barrel jack. That's not going to hold without some assistance. Right. And the stuff to the rescue again. What's left? Just the USB, the mini USB connector. I think I'm going to have to do it like this to get at it too. And just for variety, I'll use actual blue tack. Those mounting tabs for that USB don't protrude all the way through. Just barely touch them with my iron. Ow, ow. Hopefully that'll hold. Yeah, it seems to be mechanically holding. Right. Those pins don't poke all the way through very much either. Yikes. Not the best choice of components. Although I think that comes down to the fact that this is an especially thick board. So hopefully, if I get enough solder into that plated through hole, it will make contact. Yeah, I only need those two because that's the power. Oh yeah, you can see that the solder is wicked right through the hole, so that's good. That should be holding it. So the last thing to do will be to stick down these heat sinks onto each of the regulators. I'll probably be prudent to wait until it's tested to do this, but I don't think I will. I can peel them off if I have to, but I don't think I will. It's a fairly straightforward circuit, and I don't think I have done anything blatantly wrong. Tried to be a little bit careful. It's sometimes challenging how I'm talking and making sure that everything's in shot for you guys to see. Sometimes it's a little bit tricky to get all the details straight. Get that guy on there, and there is one for the 3.3 volt regulator as well. Okay, I must have miscounted earlier. Oh, there's one more LED. Oh, that goes down there. Okay. Yeah, I'm guessing that one is on the positive rail and one is on the negative rail. That would make sense. See, I declare it over a little bit too soon, and look what happens. Right, now I guess we should get some power onto it. I'm going to power it from my bench power supply here, feeding into a USB cable. And I guess I will get a meter to measure the outputs. Can you see that over there? Okay, good. So, first step, power on. Why don't I have an LED up there? Did I put it in backwards? We're drawing 130, 120 milliamps. Let's just go for it and see what we've got here. So I'll just get the meter onto it. There's ground and plus 12 volts, 12.2, good. Ground and minus 12 volts, minus 1202, good. Ground and plus 5, yep. Ground and minus 5, 4.92, yep. And then ground and 3.3 volts. Bang on. So did I get that LED in there backwards? I'm going to guess that's probably what I did. Other than that, it works. And it works well. There's no loads on it, so nothing's getting hot. That is excellent. And these being linear regulators on the outputs, and with all the capacitors in there, that's going to be a nice smooth output, which will be good for analog circuits like op amps, which tend to need a plus and minus voltage. I'm thinking this might be a good power supply for like homemade synthesizers or something like that, because they tend to need both positive and negative voltages to run their op amps and stuff, and they want a nice clean output. Even though it didn't come with instructions, it still went together pretty well, even though I was fumbling around and doing stuff with you guys and whatnot. I'm just going to flip that LED around because it's bothering me, and then we'll wrap up. Right, that's what you want to see. I think all in all, that's a pretty good kit. It's a bit of a challenge, but it's got, like I said earlier, a little bit of everything. It's got some surface mount, it's got through hole, it's got some big pads that need a lot of heat on them. It's a good little kit just as a kit, and it puts out a pretty reasonable output at the end of the whole thing. Anyway, thanks for watching. I hope you found that somewhat entertaining and weren't skeeved out too much by some of the shortcuts that I took in my crappy soldering. Questions and comments down below. Thanks to everybody in the mailbag who suggested doing this one first out of the other kits. I appreciate that. Thanks for watching. I'll talk to you later.